This is me in an inflatable boat. But not just any inflatable boat. This one has a fully electric propulsion system attached to it. Obviously. So last year I had a bit of fun with an inflatable donut that I strapped an electric motor onto and then kind of used it as a boat. But while playing around with that thing, I thought to myself, wouldn't it be cool if we could actually do this with a real proper boat that you can sit in? And so that's exactly what I decided to do. So the first thing I needed to do for that is obviously get myself some sort of boat. Now, I don't have enough space in the backyard to actually store a boat, and I also don't live next to a lake or a canal that I can put a boat into all year. So I wanted to get an inflatable boat so that I can store it easily during the winter. And this is the boat that I ended up getting, and there are a couple of reasons for that. So, first of all, this boat was quite affordable. Then it's also rather small and lightweight, which is good for efficiency and therefore range. But perhaps most importantly, it comes with this removable fin that you can attach to the bottom of the boat. And this is an excellent way to attach an electric motor to it, because the most difficult thing about trying to put a motor on an inflatable thing is the fact that you've got no good way to attach equipment or hardware to the boat, right? Because it's made of soft rubber or plastic all the way through. So the fact that this has this hard plastic fin on the bottom is an excellent opportunity for me to attach the electric motor. So that's exactly what I did. So right here, this is the original plastic fin that you can slot on the bottom of the boat, and then to that I have attached this motor mount with this electric motor and this propeller. So this is my electric thruster essentially that you can put on the bottom of the boat. So this sits completely below the water, so this is completely submerged, so you cannot see the drive system when the boat is in the water. You can see this cable that runs up into the boat, but that's it. So I think that's kind of cool, right? You can't really see what's happening. The boat just appears to be moving magically out of nowhere, but there is actually a motor hidden right underneath where the person in the boat sits. Now, this electric motor is a small brushless motor that I also used on the inflatable donut. And don't be fooled by its small size, because it can actually produce about 2 horsepower, which I think is quite impressive for such a small little motor, right? Now, running motors like this underwater is actually perfectly possible, but they're not necessarily designed for it. So while the motor works perfectly fine, there are some long-term problems that I could run into, like the water could wash the grease out of the bearings, or it could cause some corrosion, some problems like that. But short-term, it's working for now, right? Now then, to that motor I've attached this little homemade propeller, which is just a piece of aluminium that I cut out and then kind of bent into the shape of a propeller. And there's something interesting about that. Actually, I made another propeller that I've tested, which is this one, because I thought that this one would work better, but then it didn't. So why is that, right? Well, the thing about propellers is, one thing that's very important about boat propellers is the pitch. So the pitch of the propeller is essentially the angle of the propeller blades. And the greater that angle, the higher the pitch, the further the propeller moves horizontally when it does one complete rotation. So you can imagine if you have a propeller, it kind of screws itself through the water like so. And if you have a greater pitch angle, it'll move further for one rotation of the propeller. And therefore a propeller with a greater pitch results in a higher speed of the boat. So what I thought to myself is, I make a propeller, this one, with a more aggressive pitch, so that my boat will go faster. But what I didn't think of is that a propeller with a greater pitch also requires more torque from the motor to be turned. So it's very much like switching gears on a bicycle, right? If you select a higher gear on a bicycle, you can reach higher speeds for a given pedaling rate, but you also need to push on those pedals a lot harder to achieve the same pedaling rate. So what I didn't realise was that yes, in theory this propeller could make my boat go faster if it spins fast enough, right? But my electric motor didn't have enough torque to actually spin this fast enough, and so the electric motor couldn't get up to a high enough speed, and therefore it couldn't run very efficiently and it couldn't produce as much power. So therefore I put the flatter propeller on again, so the flatter propeller has a lower pitch, so the electric motor can actually spin up to a higher speed, and therefore it can reach a much higher efficiency and put much more power into the water. So therefore, counterintuitively, the boat actually goes faster with the lower pitch propeller, because essentially this was as though you're on a bicycle trying to go uphill in a super heavy gear. You just can't put the power down efficiently, so it's not working well. So I might still use this propeller in the future, but then I have to put on a bigger motor with more torque that is capable of rotating this at the right speed. Now then, from that thruster, this cable runs up into the boat where I sit, and it plugs into a speed control, which you'll see in a minute, that controls the electric motor, and also the battery pack is in the boat as well, and you can actually use whatever battery pack you want as long as you can fit it inside the boat. So I think that's enough talk about the technical specs of the boat. I think it's time to take a look at a bit of a test. So I did a test yesterday and we filmed it. I do want to apologise for the sound quality because it was near a busy road, there was a lot of traffic, so yeah, sorry about that. We might need to use a different microphone setup in the future. Anyway, here's a video of me testing my new fully electric inflatable boat. Very noisy boat behind us. Okay, so the first thing that we need to do is we need to attach the electric motor to the bottom of the boat. Just flip the boat upside down like this, then we take the electric thruster and we can just slot that into place, just like that. Now I'm going to get the boat into the water. Then we simply lower it down. There you go. Alright, so I'm on board the boat now. So as you can see, we've got this paddle over here which I use for steering the boat because it doesn't have a rudder. Then down here between my legs we have a lithium polymer battery that powers the electric motor. Then over here we have the speed control, so by turning this knob I can enable the electric motor and make the boat go forward. And then down here I've also got this current clamp that allows me to see how much electric current I'm drawing from the battery pack. So if I activate the motor, you can see we're now drawing about 1.6 amps of current, and the boat is creeping forward slowly. Off we go! Now of course this is quite boring because we are moving rather slowly, so I'm going to make the boat go a little bit faster now. So I'm just going to apply a bit more throttle. So we're now at about 13 amps of current. Right. Do you think we should test how fast this thing can go? Right, here goes. against the wind. Right, so that's it. The homemade electric boat. Surely a lot more comfortable than the homemade electric donut from last year. I hope you've enjoyed this video, and of course, thank you for watching.